Okay, so this is limiting reactants, and I always like to start off my limiting reactant lecture with a scenario like this. So if I have 200 bike tires and 25 bike frames, how many bikes can I build? So if you're looking at this problem and you read the very first part, you see this 200 bike tires and immediately say, oh, well, that will make 100 bikes since a bicycle has 2 tires. However, when you read on throughout the problem, you realize that there's only 25 bike frames. So even though I can make 100 bikes using the tires, I am limited to the number I can actually make because I'm going to run out of bike frames. So this is what we like to call a limiting reactant. So the definition of a limiting reactant is the reactant that limits the amount of the other reactant that can combine and the amount of product that can form in a chemical reaction. So for this particular problem, I have 200 tires plus 25 frames. And I know that I am only going to be able to make 25 bikes because this reactant limits me on the amount of product that I can form. Throughout this whole unit, you've seen a lot of times the terminology in excess, in excess, in excess. And I told you not to be stressed out about that we would get to it later. Anytime we see the term in excess in a problem, that's telling us that we have plenty of that reactant, meaning that we won't run out. So we don't have to worry about anything being limited. So whenever you're working a problem and you see in excess, you know that that particular reactant cannot be the limiting reactant. Okay? So what I want to do is I want to work a problem and explain to you what limiting reactant means when we're talking about math problems. So let's go ahead and grab our scratch paper. You are going to need your calculator and you're going to need, you may need your periodic table on a couple of problems. So here is our problem that I want to work. Silicon dioxide, which you know as quartz, is unreactive in most cases, but reactive, but it will react with hydrogen fluoride. All right, and here's the reaction. Silicon dioxide would look like this, plus hydrogen fluoride looks like this, and it yields silicon fluoride, silicon tetrafluoride, plus water. So before I do anything, I've got to go in and balance this, and to balance it, I'm going to put a 4 here, and I'll put a 2 here. So now I have a balanced reaction. Okay, so this is, the backstory, I guess you would call it, for this problem. So they want to know if 6.0 moles of hydrogen fluoride is added to silicon dioxide, which is the limiting, I'm sorry, this should be added to 4.5 moles. My bad. It's added to 4.5 moles of silicon dioxide, which is the limiting reactant. And from here on out, we're going to say LR to save time. So just like we've done in all of our other problems, I'm going to come up here and I'm going to write down my givens. So they're giving me 6.0 moles, and they're giving me 4.5 moles of these two reactants. And they want to know which one is the limiting reactant. Now, notice there is no unknown up here like we've typically had. Instead, they're just asking us to find out which one of these two would be my limiting reactant. So here is a clue with limiting reactant problems. If you're not sure when a problem is a limiting reactant, if they give you two knowns and they're both reactants and no unknown, that is your clue that, hey, this is going to be a limiting reactant. Now, what's great about this is they don't ask you anywhere in here to tell them how many grams or anything of either one of these we made. So I get to pick what I want to look for. So I'm just going to go over here and I want to know how many moles of this I can make. Okay, so what I'm going to do is imagine, instead of this being these chemicals, this is tires and this is bike frames, and I want to know how many bikes I can make. So what I'm going to do is I'm going to start with my first given, and I'm going to say 4.5 moles of silicon dioxide, and I'm going to solve for moles of silicon tetrafluoride. So I'm going to use my mole to mole ratio. And so when I run this through my calculator or my brain, I'm going to see that I make 4.5 moles of silicon tetrafluoride when I have 4.5 moles of silicon dioxide to start with. So I need to do the same thing with this other reactant. So I'm going to come over here and I'm going to put 6 moles of hydrogen fluoride. And then I'm going to do my molar mass with the same product, 4 moles of HF, 1 mole of silicon tetrafluoride. And then I'm going to run that through my calculator. And when I do, I get 1.5 moles of silicon tetrafluoride. Now that's pretty simple, just a simple mole to mole problem for us. Now, the whole point, though, was they want to know which one is the limiting reactant, which means that which one is going to produce the smallest amount of the product. Like our bikes, tires, and our frames, we were limited to only 25 bikes because of the frames. Well, in this case, we are limited to only 1.5 moles of silicon tetrafluoride because this is the smallest product, which means that hydrogen fluoride is my limiting reactant. So hydrogen fluoride is the limiting reactant. This tells me that if I had as much hydrogen fluoride that I needed, I could make 4.5 moles of silicon fluoride. Just like if I had all the bike frames that I needed, I could have made, 100 bicycles. But this limits me, so I'm only allowed to make 1.5 moles of silicon tetrafluoride. Okay, so throughout these problems, you're going to see that once you've established your limiting reactant, they may come in and say, okay, now tell me how many grams of silicon tetrafluoride can I make? Well, in that case, you need to just ignore this portion from here on out, and you will use this as your given because this is your limiting reactant. So you would do the same thing you did before, but then you would convert this to grams. Now, I do want to point out that you don't always have to pick this as your product. I could have easily chosen water if I wanted to, but just to make things easier, I went with silicon tetrafluoride because it only had a 1 as the coefficient, and that made my math just a little bit easier, okay? So, a couple of things that you need to remember when working limiting reactants. If your knowns or givens are both on the reactant side and they don't ask you for an unknown on the product side, then you're probably dealing with a limiting reactant. Also, the other clue is if they ask you what is the limiting reactant, you know this is going to be a limiting reactant problem, and you're going to have to work it. For this case, we're only going to have 2 reactants, 2 problems. You'll work it for one known, then you'll work it for the other known and search for the product. Now, had this been 4.5 grams, and 6.0 grams, I would have had to convert from grams to moles and then from moles to moles using the molar mass. So you can use any of those problem types that we've done before. You just need to remember that you will always work 2 problems. Now, I've given you some practice problems on limiting reactants, and I would ask that you go through those and practice those. And then we're going to have another Zoom session on Tuesday, and on Tuesday we'll work through a few more limiting reactant problems together. Thank you.